Good morning, class. Today we are going on to a new topic that is chapter 6, and that is called Binomial Theorem. Okay, first of all, I would like to introduce a symbol to you. This looks like an exclamation mark, but it's not an exclamation mark. It's called factorial. The word is called factorial. Now, we can read this as the factorial of 3 or 3 factorial. Now, what does 3 factorial represent? It means 3 times 2 times 1. That means you start from 3 and you decrease all the way to 1 and you take the product. Okay? For example, 5 factorial will mean 5 times 4 times 3 times 2 times 1 and so on. Okay? So, if in algebra we use n factorial, it will be n, then one number less than n is n minus 1, then n minus 2, all the way until 3 to 1. This will mean n factorial. And in maths, we define 0 factorial as 1. Okay? We define 0 factorial as 1. Okay? Now, next we are going on to example 1, and that is found on your page 137 of your textbook. The question says, simplify. Okay, without using a calculator, evaluate 4 factorial times 3 factorial. Now we know that 4 factorial is 4, 3, 2, 1, and 3 factorial is 3, 2, 1. We find out the answer and then we find the product. This will be a 1, 4, 4 for example 1a. Now let's take a look at 1b. What did they say? They say to simplify n factorial over n minus 1 factorial. Now n factorial is n, then n minus 1, n minus 2, all the way to 3 to 1. N minus 1 factorial is starting from n minus 1, then n minus 2, because n minus 2 is 1 less than n minus 1. Okay, all the way to 3 to 1. Now you can see that all these terms will cancel off except n, so the answer is n. Okay, so that's how we simplify example 1 on page 137. Okay, now then there's a notation that we have to learn. Okay, the notation is bracket n on top and r below. This is read as n choose r. Okay, it can be found on page 138. It is read as n choose r. Now, we can represent it this way, or we can write n choose r. Okay, n cr, n on top and r below. So if we write n choose r or n cr is equals to, this means is n factorial over r factorial, n minus r factorial. That means n, then r, then n minus r factorial. This formula is given on page 138, where n and r are integers and r is between 0 and n. Note that r is between 0 and n, okay? It's inclusive of 0 and n, alright? So what does this mean? How do we apply it? For example, if I have 13 choose 6, or I can write it as 13 choose 6, this will mean 13 factorial over 6 factorial. Now 13 minus 6 is 7, so it's 7 factorial. This is how we do it numerically. So it's 13 factorial over 6 factorial, 7 factorial. Okay, so this is the meaning of the factorial and n choose r. How do we manipulate it? Alright, so that will be your notation for n choose r. Now we can also find 13 choose 6 with the calculator. Now you look for the calculator, the symbol n choose r. Now this is found somewhere on top of the function key. Okay, somewhere on top of the function key. Now if we have 13 choose 6, we will key in 13 n choose r6, and they will give you the answer. Okay, so 13 n choose r6, the answer will be a 1716. So that's how we key in n choose r with the calculator. This will be illustrated again later on in my examples. Okay, so this will be your notation for n choose r. Now we are going on to example 2. Okay, now they say evaluate 8 choose 2, so it's 8 factorial, 2 factorial, 6 factorial. We can just key in the calculator, the answer will give us 28. So you use your calculator, look for NCR, press 8 NCR2, that means 8 choose 2. The screen will show the answer as 28. Okay, it doesn't matter whether you're using your Casio calculator or your short calculator, you should find the function NCR. Okay, and it is very clear that when you press the calculator in this manner, you will get the answer as 28. Okay, now next I'm going on to part B. The question say, show that 20 choose 4 is this. Okay, now I'm going to show 20 choose 4. Now you cannot use your calculator because you're supposed to show this. You're not supposed to find out the answer, so therefore you have to show. So 20 factorial over 4 factorial, 16 factorial. Now if I have 20 factorial, I have 20, 19 all the way until 1. 4 factorial means 4, 3, 2, 1. 16 factorial means 16, you decrease until 1. Now you will see that from 16 onwards, all these are being cancelled off. And on top, I'm left with 20, 19, 18, 17. And below is 4 factorial because 4, 3, 2, 1. So it's already proven that 20 choose 4 is this. Okay, it is already shown in the proof here. Now, why are they introducing you this term? Because there's another formula that is on page 139 that you can refer to. Now, what do they want us to show this for? Now, can you see that when you have 20 choose 4, below is 4 factorial, on top there are 4 terms, 20, 19, 18, 17. So there are 4 terms. Okay, so let me just give you 2 numerical examples first. If you have 10 choose 3, it will be 3 factorial, on top is 10, 9, 8. Can you see there are 3 terms here? Okay, so if you have n choose 3, I will have n, then n minus 1, n minus 2. 3 terms here, and down here 3 factorial. Okay, this can be summarized in the general formula that's in green here. If you have an n choose r factorial will be here. So you decrease n minus 1 all the way until n minus r plus 1. Okay, this will mean that on top there will be r terms. Okay, there will be r terms. Alright, so I repeat, if it is 20 choose 4, I will have 4 factorial below, and on top is 4 terms. Starting from 20, you decrease. Okay, this can be illustrated in these 2 other examples that is in blue and red. And the general formula will be the one given in green here, and it is found on page 139 of your textbook. Now, it may look very difficult in the beginning, but do not worry, with much practice, we'll be able to do it. Okay, so this is what we have for example 1 and 2. Now, I'm going on to example 3. Okay, example 3 says that if n is bigger than 3, find the positive integer of n such that this is equals to this. Now, I always do it from basics. I do not use the formula that they've given. Okay. Now, n choose 3 means n factorial over 3 factorial, n minus 3 factorial. And n choose 1 means n factorial over 1 factorial, n minus 1 factorial. Okay. Now, I am going to write this out. Okay, in the long-winded way. So I have n minus 1 all the way until 1. 3 factorial is 3, 2, 1. N minus 3 will be n minus 3, n minus 4 all the way until 3 to 1. Now for this part here, can you see that n minus 3 onwards is being cancelled? I'm left with n minus 1, n minus 2, and below here I have 6. Okay, now I'm going on to simplify this side. Okay, now what does it mean here? Can you see that n factorial means n minus 1, n minus 2 all the way to 1. 1 factorial is just 1. Okay, n minus 1 factorial is n minus 1, n minus 2 all the way to 1. You can see that all this cancels off and I'm left with 5n. So 5n here. Now, because they say that n is bigger than 3, that means n is a positive number. If it's a positive number, we can divide both sides by n. so that I can reduce to this equation. Okay, now if they did not tell you n is bigger than 3, you cannot divide by n, because n may be 0 and you cannot divide by a 0. Okay, you cannot divide an unknown unless you know that it is not 0. Okay, so I will have this. I use the quadratic, I use the cross method, because they say n is bigger than 3, therefore negative 4 is rejected. I'll have just n equals to 7. Okay, that will complete your example 3. Alright, moving on, we are going to introduce to you a special pattern of numbers that is called the Pascal Triangle. Okay, now before I go on to the Pascal Triangle, I need to introduce to you what are binomials. Now, expressions such as x plus y and 1 minus x, can you see that all these contains two terms? So they are called binomial. Just like bicycle, there are two wheels. Okay, so binomials consist of two terms. Alright, now then I want you to observe something here that is very interesting, and this is how we define the Pascal triangle. Okay, now if I have x plus y to the power of 1, it's just x plus y. If I have x plus y to the power of 2, I will have x squared plus 2xy plus y squared. I apply the a plus b whole thing square formula. Then x plus y to the power of 3, I'll take x plus y times this. Okay, so when I simplify, I'm not showing the simplification here, I'm giving you the final answer. I'll have x cubed plus 3x squared y plus 3x squared plus y cubed. Now, if we move on to x plus y4 and I expand it in the long-winded way, the final answer will be this. Okay, now I just want to take note here. Alright, take note that the coefficient here is 1 and 1. This is a 1, 2, 1. This is a 1, 3, 3, 1. This is a 1, 4, 6, 4, 1. Okay, now how does the Pascal triangle work? Can you see that it's surrounded with 1? So we have 1, 1 here. Now, this and this will add up to 2. That if I have 1 here, this is one row, I'll have 3, 3, 1. Then I have 1, 4, you add up, 3 plus 3 is 6, 4, 1. Okay, now I want to take note that, alright, this 1 and 1 here is the coefficient of this. Okay, is the coefficient of this. Alright, now I repeat. This 1 and 1 here is the coefficient of the first expression here. This 1, 2, 1 is the coefficient of 1, 2 and 1 here, the second expansion. 1, 3, 3, 1 is here, 1, 3, 3, 1. And to the power 4 is 1, 4, 6, 4, 1. So 1, 4, 6, 4, 1. As you can see, the rows can go on and on and on and on. And we can get a very big Pascal triangle. Okay? Then, the textbook suggests that we use the Pascal triangle to expand binomials. But it is very inconvenient because as the power gets more. Now, when this is power 4, it's 1, 4, 6, 4, 1. What if it's power 10? Then you really have to do a lot of rows and it might get messy and the coefficients will get lost or you may make mistakes. Okay, so for Pascal triangle, I just need to know that it is a special pattern of numbers. We are not going to use Pascal triangle to do binomial theorem. Okay, and I have to state this that I'm combining 6.1 and 6.2 together because the basic thing that you need to know about binomial theorem is how to expand a binomial. Okay, so for this section, I'll be just concentrating on how to expand a binomial. Okay, alright. Now, before I carry on with example 4, 5 and so on, I'm going to show you the binomial theorem. Okay, now if you turn to page 146, you will see this page 146, this binomial theorem here. Okay, now this is the binomial theorem that you must know, and bear in mind that this binomial theorem, the formula here will be given in the formula list in the exam. Now, the formula that is given on page 142 is just a simple version of this. Okay, this is a simple version of this where your A is equals to 1. So there's no need to know 2, you just know the second one will do, because you just need to replace A by 1 in this particular formula on page 142. This is a simpler case of this. Okay, so we just have to remember this, and we don't even have to memorize this, we just know how to apply this will do, because the formula is given in the formula list. Now it looks very terrible here, but I'm going to explain to you in numerical examples, with numerical examples. Okay, now I'm going to write the binomial theorem here again. Okay, a plus b to the power of n is just an, so on and so forth. Now what does it mean? Okay, what does this mean? Now I'm going to use the example here. Expand 2 plus x to the power of 4. Okay, now if we follow the theorem, a to the power of n is the first term. So 2 to the power of 4 is the first term. Plus, n choose 1. Now, personally, I prefer to write like that. 4 choose 1 because I can relate to the calculator better. But if you choose to write like that, it's also okay. They mean the same thing. Okay, so n choose 1. So in this case, it will be 4 choose 1. Then a, now if this is 4, this is minus 1, so this will become 3. Then b power 1, 1. Okay, then 4 choose 2. Can you see you decrease? 4, 3, then 2. Then you increase this one, 1 to 2. So you have this. Okay, then you continue. 4 choose 3, 2 to the power of 1, x cubed. Alright, then finally this will just be x4 because this is the final term. Now how to remember this? Let me just tell you how to remember this. The first one will be the first term to the power of 4. The last one will be the second term to the power of 4. Okay, then it will be 4 choose 1, 4 choose 2, 4 choose 3. Okay, then you can see 4, then I decrease, become 3, then 2, then 1. Okay, now bear in mind, if this is 4, I will have 5 terms. 1 term, 2, 3, 4, 5. There's always an extra term. Okay, that means if I have power 6, I will have 7 terms. It's always true. Alright, and one more thing is that when the two powers add together, 3 plus 1, it must be 4. 2 plus 2, it must be 4. 1 plus 3, it must be 4. 4 is of course 4. 4 is of course 4. Okay, so this is how we check the intermediate steps so that we will not make mistakes. Okay, now bear in mind one more thing that you can check. When this is choose 1, this will be power 1. When this is choose 2, this will be power 2. Choose 3, this will be power 3. So there are various ways that you can choose. So what is the trick here that you choose? Now let me just show it to you again. When it's power 4, you will have 5 terms. 1, 2, 3, 4, 5. One more term. That means if it is to the power of n, I will have n plus 1 terms. Okay, always one more. And the first and the last is always the first term raised to the power, the second term raised to the power. Then 4 choose 1, this will be 1, then you decrease the power accordingly. Now for this part here, you just need to press the calculator. 4 choose 1 times 2 to the power of 3, you will get 32. Okay, this one you press 4 choose 2 times 2 to the power of 2, you will get 24. 4 choose 3 times 2, you will get 8. Okay, so all these coefficients, you can get it with the calculator. Alright, now I think it's quite terrible if I give it to you like that. So I'm going to do more examples so that you can understand what I'm saying. Okay, alright, now can you look at example 4 on page 140, part 1. The question says, use the Pascal triangle to find the first 5 terms in ascending powers of b in the expansion of this. Okay, 1 plus b to the power of 7. They want the first 5 terms. Now, I'm not using the Pascal triangle. I'll be using the binomial theorem. Okay, so let us apply the binomial theorem here. Okay, I am going to explain again how we use the binomial theorem. Now, can you see that this is 1, I raised to power 7. Then 7 choose 1, 1, 6, B1. Okay? Then 7 choose 2, 1, 5, B2. 7 choose 3, 1, 4, B3. 7 choose 4, 1, 3, B4. Now, how to double check? When it's choose 1, power must be 1 for B. Choose 2, power 2. Choose 3, power 3. Choose 4, power 4. And when the two powers add up, it must give me 7. Okay? Because the question wants the first 5 terms, you just give the first 5 terms. 1, 2, 3, 4, and 5. Don't forget, there are some more terms. So we need to write plus dot dot dot. We do not have to find out what are the terms there, but we need to say that there are some more terms that is behind. So if we press the calculator, we are able to get this answer. Okay, plus dot dot dot, because there are some more terms behind, and this will give us the first 5 terms. Okay, so this is how we expand example 4, part 1. Now, if you need to replay this and look at it again, please feel free to do so. Alright, now, part 2. Hence, deduce the first 5 terms in ascending powers of b or x in the expansion of this. Now, we know from part 1 that 1 plus b is this. So when it's 1 minus b, is actually 1 plus minus b. So I'm replacing b by minus b. So I replace all the b by minus b, and I will get this. Okay, now what's the difference between the two? Okay, what's the difference between the two? Let's look at the green one. Okay, let's take a look at the green one. Okay, now can you see that when it's a plus, all the signs here are plus. When it's a minus, it's alternate. Plus, minus, plus, minus, plus, minus. Okay? Now, some students will ask me, if it's a minus, is it okay if I put a plus here? It is fine. You always put plus dot dot dot. It doesn't matter. Even if this is a negative term, it's just plus negative. Positive and negative will still give me negative. So it is of no concern. You just put plus dot 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 will do. Okay? Now, as for example 4, part 2b, 1 plus 2x to the power of 7. Now, you can see that I can replace b by 2x in this particular expansion. So, I replace b by 2x, I will get this answer. Okay, so it's just replacing b by 2x, I will get part 2, part b of example 4. Alright, okay, so that will conclude the example 4 of binomial theorem. Take note that I will never use the Pascal triangle. That's just for your information. Okay, we will always use the Pythagoras theorem. Not Pythagoras theorem, I'm sorry, the binomial theorem. Okay, alright, next I'm going on to example 5. Okay, let's take a look at example 5. What is it talking about? Okay, this is found on page 142. 142. Okay, 1 minus 2x to the power of 5. I'm going to apply the binomial theorem again. 1 to the power of 5. 5 choose 1, 1 to the power of 4, negative 2x power 1. Now, you must take this as a whole thing. Okay, you must have the negative. If not, there will be mistakes. Alright, you treat it as you treat it as a plus b to the power of 5. Then this b is a negative 1, negative 2x. Okay, so negative 2x power 1 plus 5 choose 2, 1, 3, negative 2x to the power of 2 plus dot dot dot. Because the question wants you to get the first 3 terms, so we just get the first 3 terms, 1, 2, and 3. Then you plus dot dot dot. Now I key in the calculator, I'll be able to get this answer. Okay, now next, I'm supposed to expand this to the first 3 terms as well. So I'm going to use the binomial theorem again. 1 power 9, so on, so forth. Okay, remember to put the brackets, then plus dot dot dot. I key in the calculator, I will get this. So expanding this and this will make use of the binomial theorem. Okay, now let's look at part 2. Hence, find the expansion of 1 minus 2x to the power of 5, 1 plus 3x to the power of 9, up to the term in x. Let me just take a look first. Up to the term in x squared. Now, what we do is that we put the first expansion here, we put the second expansion here. You are supposed to find the expansion up to the term in x squared. So when I take 1 times 1 is 1. 1 times 27x is 27x. 1 times this is 324x squared. Okay, then I move on to the second term. Negative 10x times 1 is negative 10x. This times this is negative 270x squared. This times this is no longer feasible because it becomes x cubed. We do not want an x cubed. Okay, then we move on to the next term. 40x squared times 1 is 40x squared. 40x squared times 27x is no longer needed because it's x cubed. So we just have this, and don't forget to say plus dot 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 because there are some more terms. We are just expanding up to x squared. So we simplify this, we group the like terms together, we'll get 1 plus 17x plus 94x squared plus dot dot dot. So that is how we do the expansion for the term up to x squared in part 2. Okay, so that will be example 5. Now, like what I've said, I'm just concentrating on expansion, so I'm not going to do example 6. I am straight away going to do example 7 on page 146. Alright, on page 146. Now, let's look at example 7. Example 7 says that you are to find the first 4 terms in descending powers of x in the expansion of this. They want the first 4 terms. So first, raised to the power 5. 5 choose 1. We follow the binomial theorem until we reach the first 4 terms. And then you plus dot dot dot. Then we will expand this. 2 to the power of 5 is 32. x5. Sorry, I make a mistake here. This is x5. 32 x5. Then you key in the calculator. 2 to the power of 4. And then 3. You can find out the coefficient. Okay, likewise, simplify this, keying in the powers and x cubed. Simplify this, keying in the powers. Okay, key in appropriately and correctly. If not, you will not get the correct answer. Okay, so by keying in the powers, so you key in 5 choose 1 times 2 to the power of 4 times negative 3, you will get this, and this is x to the power of 4. You key in 5 choose 2, 2 to the power of 3, negative 3 to the power of 2, you will get this coefficient and it's x cubed. Okay, likewise for the following ones. Okay, now I'm moving on to part B. Now part B looks difficult, but actually it is not. Now first I apply the binomial theorem. X to the power of 6 plus 6 choose 1, x power 5, then the second term raised to the power of 1, so on. 1, 2, 3, 4. I do until the 4th term, I plus dot dot dot. Okay, now this is x to the power of 6. 6 choose 1 is 6. Now you have x5 over x squared, so it's x cubed left. Now if you press this, it will be 15. Now this is x4 over x4, it cancels off, so it's a constant term, 15. Now if you likewise key in this one, you will get 20 x cubed over x6, so it's x cubed below plus dot dot dot. Okay, so we are still applying the binomial theorem, and that's how we get our part B in this particular example. Okay, now part C is the one that we have problems with, or a lot of students have problems with, and I'm going to explain to you clearly here. Alright, before I start anything, I'm just going on with the binomial theorem, how to do it properly in the first instance first. Alright, they want the first 4 terms, so let's take a look. Okay, I will not show you everything because it's rather confusing, so I'm going to show you step by step. Okay, now first of all, x to the power of n plus n choose 1, x, you decrease 1, n minus 1, then negative 2x raised to the power of 1. Okay, n choose 2, x, n minus 2, negative 2 over x to the power of 2, plus n choose 3, x, n minus 3, negative 2 over x to the power of 3, plus dot dot dot, because there are some more terms to come. You are not supposed to forget the plus dot dot dot. Okay, now it seems very difficult, so now I'm going to show you how do we find n choose 1. You cannot key in a calculator because n, you do not know the value. Okay, I'm going to show you over here. Now, n choose 1 means n factorial over 1 factorial n minus 1 factorial. For n factorial is n minus 1, n minus 2, so on until 3 to 1. 1 factorial is just 1. N minus 1 factorial is n minus 1, n minus 2, all the way until 3 to 1. You'll realize that I can cancel all this and the final answer is just n. Okay, so I will have n here. This one gives me n. So I'll have n here. I'm combining this, I'll get negative 2 over xn minus 1 over x. Okay, I'm just multiplying these two together. Okay, likewise, I'm going to simplify n choose 2. How do we simplify n choose 2? N factorial over 2 factorial, n minus 2 factorial. That means I will get n minus 1, n minus 2, all the way until 3 to 1. 2 factorial is 2 times 1, n minus 2 is n minus 2, n minus 3, so on and so forth until 3 to 1. You'll see that from n minus 2 onwards we can cancel, and you are left with n minus 1 over 2. Okay, so n choose 2 will give you this answer, n minus 1 over 2. Okay, then I'm going to expand this. Can you see that negative square is a positive? So I have 2 square, I'll get 4. xn minus 2, because this is x2, I will have x2 over here below. Okay, now n choose 3 is the same as how we do n choose 1 and n choose 2. We will put n factorial in this form, 3 factorial in this form. Now n minus 3 factorial is n minus 3, n minus 4, so on until 3 to 1. We can cancel, and this is the answer for n choose 3. So n choose 3 is just this answer, and negative 2 to the power of 3 is negative 8. So I have n x minus 3 over x3. Okay, now, finally, now, don't forget to plus the dot dot dot. Okay, finally I have xn. Now, because this is negative, I take out 2 times n, 2n, xn minus 2. Because this is power 1. We use the laws of indices, is minus 2. Plus, now, can you see that this can cancel off? This is a 1, this is a 2. Okay, I repeat, this is a 1, this is a 2. So that's why I get a 2n n minus 1, then xn minus 4. Because I use laws of indices, I minus, so it's 4. Now, because this is a minus, I get a minus here. This divided by 2 is 3, this divided by 2 is 4. So I have 4n n minus 1, n minus 2 over 3. Now, n minus 3 over x3, xn minus 3 over x3 is xn minus 6 plus dot dot dot. Okay, that's how we get the answer for part C of your example 7. Now, if you need to go through this particular example again, please feel free to go through it again. Okay, and know how to simplify all this, because this is a common type of question that can come out in the O levels. Okay, now I will stop at example 7. Okay, now the homework for today is very simple. It is just notebook homework, and you are going to do 6.1 question 1a, 1b and 5, and 6.2 question 11. Now take note that if the question asks you to use Pascal Triangle, please do not use Pascal Triangle. Use Binomial Theorem. So you will do these questions, and we'll discuss these questions at the next lesson. Okay, and I just want to reiterate one point here, that this particular formula for Binomial Theorem, will be given in the formula list in the exam. So there's no need to memorize it. You just need to know how to apply it. Okay, and one more thing is that for Pascal Triangle, you just know how we get the coefficients will do, and there's no need to memorize the coefficients, because it's very difficult to memorize all the coefficients, especially when the power increase to a large number. Okay, and one thing that I want to take note of is when this is power 4, I'll have 5 terms, always 1 term more, and all these powers must add up to 4. Okay, and when it's choose 1, the second one will have power 1, choose 2, x will have power 2, and choose 3, x will be power 3. Okay, that means the second term here will always be raised to, when it's choose 1, you raise to 1, choose 2, you raise to 2. Okay, after much practice, you will realize that it's actually quite easy to apply the binomial theorem, and the binomial theorem is one of the topics that you can score in your O-levels. Okay, that's all for today's lesson. Thank you, class.